All right, so I wanted to go over like one problem off your homework completely and do a little bit of other stuff on some of the other problems just to kind of talk through things. So I'm going to start with problem 3. And I think the thing you guys are going to have the most trouble with, and I get this, is you're going to have the most trouble finding the vertex. It is just the most difficult thing. It's the one that requires obviously the most amount of work. So I wanted to go over how to find the vertex completely on this problem. So from that awesome video that you guys loved so much yesterday, we learned that to find the vertex, I did the opposite of B over 2A. So I'm going to go up here above my problem first, and I'm going to write my standard form, which we reviewed yesterday, y equals ax squared plus bx plus c. So what that tells me is that a is 4, b is negative 10, and c in this case there isn't one, so that means there's a 0. Hey, that should help you with your y-intercept for this problem. So if our problem says the opposite of b, and b is negative 10, the opposite of negative 10 is positive 10. So it'll be positive 10 divided by, remember I got that from here, it's the opposite of b, so the opposite of negative 10, which is positive 10, divided by 2, because there is always a 2 there. This 2 is always in the denominator, it's just part of the problem every time. So divided by 2a. Divided by 2a. So a in this problem is 4. So I'm going to plug in 4 here for a. And again, that's because a is 4. And you can use your fancy fraction to help you out with this. And you can put it, it does work out to be a pretty decimal, or you can put it in fraction form. I'm fine with whatever. If you put it as a decimal, it is 1.25. So what you have right now is you have half of your vertex. You know the x value of your vertex is 1.25. So I'm going to write that in here for my vertex, 1.25. That is half of my vertex. The second half of the vertex, that's the part I think yesterday that you guys were struggling with the most. So to find the second half of the vertex, I take my equation, my entire equation, which was y equals 4, and instead of x, I'm going to put a parentheses, squared, minus 10. Instead of x, I'm going to put a parentheses, and in these parentheses, I am going to fill in the value that I just came up with for x. So in these parentheses, I'm going to fill in the value that I just came up with for x. And what we just figured out x was is 1.25. So that's what's going to go in here. So instead of the parentheses, I'm going to put in there 1.25. And once you get it set up, setting it up is literally the biggest part of the battle, because once you get it set up, all you have to do is put it in the calculator and see what it gives you. Which it gives you negative 6.25. So when you plug all this in, it gives you negative 6.25. And now what I have is the second half of my vertex. So now I have the second half of my vertex. Well, then I can go through and I can find all my other stuff, because what we know is that our axis of symmetry comes from half our vertex. So our axis of symmetry is x equals 1.25. And then my maximum or my minimum and my range both come from the negative 6.25. That is the other part of my vertex. So I'm going to go ahead and fill those in. Now, to decide if our graph is a maximum or minimum, we need to look at which direction the graph opens. And the way we decide that is we need to find out, is our graph smiling at us or is our graph frowning at us? We need to decide. And yes, I'm making those weird looking faces that I was making yesterday in class. So the way I decide if it's smiling, if it's positive, or if it's frowning because it's negative, is I look at A. And I just have to decide, what is the sign of A? Is A a positive number or is A a negative number? Well, if you look at 4 right here, 4 is positive. So that means that since 4 is positive, then my graph is happy and it's smiling at me. And that tells me that my vertex, this very bottom point down here, is a minimum value. The reason I know it's a minimum is because it's at the bottom. And the reason I know it's at the bottom is because my graph was smiling at me. And the reason I know it's smiling at me is because 4 was positive. And then for our range, we've talked about this the last couple days, is going to be y. And then we have to decide, is the alligator eating y or is the alligator eating negative 6.25? Well, remember, negative 6.25 is a minimum. That means it's the smallest. Well, the alligator never wants to eat the smallest. The alligator always wants to eat the biggest, which means that the alligator needs to eat y is greater than or equal to negative 6.25. The last two things here, the domain. Well, the domain is easy because the domain is always the same thing every time. Negative infinity is less than x, which is less than infinity. Every single time, that doesn't change. And the last part of our problem that we haven't found is our y-intercept. Remember, our y-intercept, it's always c. Whatever c is our y-intercept. And our y-intercept is always in an ordered pair of 0 and then some number. That's what y-intercepts always look like. And in this case, that some number is 0. And I got that 0 from C here. Okay, so I'm going to look at problem 5 with you on the back and just help you get started on this one. I'm going to help you with getting the vertex set up. So remember, to find the vertex, we need to know our equation of standard form, which is y equals ax squared plus bx plus c. So that tells me in this problem a is 1/2, b is negative 3. So when I look at what it asks of me, it says to do the opposite of b. Well, b is negative 3, and the opposite of negative 3 is positive 3. So I have positive 3 divided by 2, because there's always a 2 there. Every time, this 2 is just part of the formula. Divided by 2a. A in this case is 1/2. And again, I would use your fancy fraction to see what you get. And you should get, for the answer to this problem, the number 3. So that tells us that half of my vertex, the x value of my vertex is 3. And now my job is to find the second half of my vertex, the y half. So to find the y half, I take this whole function, every bit of this, and I'm going to rewrite it, but instead of x, I'm going to use parentheses. So 1/2 parentheses squared minus 3 parentheses minus 4, and I'm going to fill in those parentheses, both of them, with the number that we just found, and that number was 3. So I'm going to take each of these two parentheses and I'm going to put in them the number 3. And I'm getting that 3 because that's what we found for the first half of our vertex. And then we just have to do some math. So I'd put all that in the calculator at one time. And typing all of that in gives us negative 8.5. So that, not 8.2, sorry, 8.5. So that is the second half of my vertex. So now that you have your entire vertex, you can go back and you can figure out what your axis of symmetry is and what your maximum or minimum and your range are. So to look at this problem, just to kind of address something, again, how do we know if it has a max or min? We look at this number here. We look at A, and we have to decide, is our graph going to be smiling at us or is it going to be frowning at us? And we decide that by this number, if this number is positive or negative. If it's positive, that means that our graph is happy and it's going to smile at us. A big, big, big smile. See, there it's smiling, it's happy. There's a little nose and everything for it. There's a big, big smile there. And if it's smiling at us, then our graph has a minimum value for the vertex. So this assignment, do not forget, you must turn this in before you leave today. Okay, you should be done with it, and you've got to turn in, you've got 2 things that are due today. Sorry, actually you have 4 things that are due today. You have 11.1, which is the graphs, 11.2, this assignment right here, and the week 4 bell ringers. So make sure you turn in all 3 of those before you walk out the door today. Y'all have a great weekend.